Hi guys, today we're going to work on section 2-2 linear relations and functions. What we're going to do is compare and contrast linear and non-linear relations, evaluate their functions, and write some linear equations in standard form. Let's get started. So linear relations are relations that have a straight line graph. So you might have seen them before, and typically you're used to them with this positive slope or negative slope. Those are called linear because literally the word line is in their name. They're a straight line. Relations that are not linear or not straight lines, they have a non-linear relations. So here's some example of linear relations. 4x minus 5y equals 16. Just think anything that I could rewrite in the form y equals mx plus b is possibly going to be linear. Non-linear, if I notice something, this has a power of 2 exponent. This one has a square root. Right here we have x and y being multiplied by each other. And then here I have an x in the denominator. All of those are key things that would let me know that this is non-linear. Here's some info about that. So to be linear, it has to follow these rules. You can have no operations besides addition, subtraction, and multiplication of a variable and a constant. So a constant's a number. So multiplication of a variable and a constant would be like 3x or 1/2 x. And then I could have something with addition or subtraction like 3/2 x plus 2 or 1/2 x minus 1. And y is equal to those. These would be examples. Variables cannot be multiplied together, so I won't have something like x, y, z equals k. Something like that would not be linear. Anything with variables in the denominator, like 1 equals 2 over x, this is not linear. And variables do not have any exponents other than 1. So like y equals x squared plus 2x plus 3. Because it has that exponent of 2 there, then I know that that is not linear. So we're going to look at these and state whether they're linear or not. Looking at letter A, I'm going to say yes, because I have a constant times a variable, and I just have addition or subtraction here with that 8. On letter B, actually looking at this, letter in B, A and B are actually the exact same problem. So of course, yes, it is linear. Looking at this one is not linear. See if you can figure out why. It's because it has a x in the denominator. And then looking at the final one, we have to decide if this is linear or not. I'm going to say not. See if you can figure out why. It's because variables are being multiplied by each other. Okay. All right, moving forward, here's an example of how we're going to evaluate a linear function. So to evaluate typically is when you plug something in and try to find a solution. The growth rate of a sample of Bermuda grass is given by this function. F of x equals 5.9x plus 3.5. F of x is the total height in inches, and x is how many days after the initial measurement. How tall is the grass sample after 3 days? So what this is telling me is that x is 3. And I need to plug in 3 for x in this equation. So 5.9 times 3 plus 3.5. And this is simple calculations. I'm going to pull up my calculator here. 5.9 times 3 plus 3.5 is 21.2. Think about what that means in context of the word problem. It means after 3 days, the grass is 21.2 inches tall. Inches tall in 3 3 days. All right, so continuing on with that same little problem there, the term 3.25 in this function represents the height of the grass when it was initially measured. The sample is how many times as tall after 3 days. So read this carefully, how many times as tall? So I'm trying to think like 3.25 times what would give me 21.2. So in order to figure that out, I'm just going to go in reverse. So I'm going to do 21.2 divided by 3.25. And again, that's something I could just pull up on my calculator. So divide it by 3.25. And I'm going to go ahead and estimate about 6.5. 6.5 times as tall. That's some fast growing grass. So after 3 days, it's 6.5 times as tall as it was the initial day. So here's the last part. If the Bermuda grass is 50.45 inches tall, how many days has it been since it was last cut? So let's recall our equation for the Bermuda grass growth. 5.9x plus 3.5. So right now, if the Bermuda grass is 50.45 inches tall, so what they gave us here is basically the f of x. That was given to us, and we have to solve for x. So 50.45 equals 5.9x plus 3.5. So let's go ahead and solve. So subtract 3.5 from both sides. 3.5. So again, I'm just going to use my calculator here. 50.45 minus 3.5 is 46.95. Equals 5.9x. So then divide by 5.9. So again, just use my calculator. Divided by 5.9. And I get 7.95. I'm going to go ahead and round that, 7.96. So make sure that your answer makes sense in context of the word problem. If the Bermuda grass is that tall, how many days has it been since it was last cut? I'm going to say about 8 days. It's really close to 8 days. So let's talk next about standard form. Standard form, it's a form of linear equation. It can be written in this way. I don't like how that came out, so I'm going to rewrite it. ax plus by equals c. A has to be a positive integer, so a positive whole number. B and C must be integers. A, B, and C has the greatest common factor of 1. So basically all these letters, A, B, and C, have to be integers, where A has to be a positive integer. So no fractions or decimals. Let's see how this works out. So we're going to take this problem right here and rewrite it in standard form. So one thing I know, let me rewrite standard form up here, ax plus by equals c. I know that my x and y have to be on the same side of the equal sign. Good morning. So since my x and y have to be on the same side of the equal sign, I'm going to go ahead and move that y. So I have negative 3 over 10x minus 8y equals negative 15. Next thing I know is that a, b, and c have to be integers, so let's clear this fraction. So I'm going to clear this 10 out. So I'm going to multiply everything in here by 10, and let's see what I'll be left with. Negative 3x minus 80y equals negative 150. Finally, don't forget that a has to be positive, so I'm going to multiply everything in here by negative 1. What you do to one side, you have to do to the other side as well. So 3x plus 80y equals positive 150. So now I am in standard form. My a is positive and I have all integers here. So let's see, a is 3, b is 80, and c is 150. Alright, I do want you to try these on your own, so I'm going to pause here, and I want you to pause and take a second to try to work these out and see if you can write them in standard form. Alright, I have shown my work here. Double check and make sure that you were able to get it correct on your own. So here's a little bit of vocabulary that we're going to talk about, the x and y intercepts. The x-intercept is where my graph crosses the x-axis. So it's written as a coordinate, whatever that x-intercept is, whatever that x value is, comma 0. So on this one, my x-intercept is 1, 2, 3, 4, 5, 6, comma 0. My y-intercept is wherever my graph crosses the y-axis. So it's written as 0, comma y. So let's see what my y value is, negative 1, 2, 3. So 0, comma, negative 3 is how I would write the y-intercept of this. So on this example, we're going to use the intercepts to help us draw a graph. So the interesting thing about the x and y intercept is the x-intercept occurs wherever y is equal to 0. So whenever I'm trying to find the x-intercept, first let me go ahead and put this in standard form by subtracting 8 on both sides. Whenever I'm trying to find the x-intercept, I'm going to plug in 0 for y. So when I solve this, I will have, this would cancel here. So 2x equals negative 8. So x equals negative 4. So my x-intercept would be negative 4, comma 0. My y-intercept occurs wherever x is equal to 0. So again, I'm going to start in standard form. 2x minus 3y equals negative 8. But this time I'm going to plug in 0 for x. So this would cancel here. I have negative 3y equals negative 8. And when I divide by negative 3, a negative divided by a negative is positive. So I would have 0, comma 8 over 3. So when I graph this, this is going to be a crude sketch. If I graph my y-intercept 0, comma 8 over 3, let's see, that's 1, 2, it's between 2 and 3, so about right there. And then when I graph my x-intercept, negative 1, 2, 3, 4, when I connect these two lines, I will have officially drawn my graph. I'm going to do it in green. Connect those 2 points, and I can draw my linear graph. It's a little bit easier to do when you have a ruler, but I don't have one. Please forgive me for that. Alright. So I want you to try on this one. See if you can find the x and y intercepts. So go ahead and pause here and see if you can graph it. Alright, go ahead and check your solutions with my solutions. I got 5, 0 for the x-intercept and 0, 2 for the y-intercept. And here's a crude sketch of my graph. Alright, have a good day.